Day 8, solving quadratics by completing the square. Today we will be able to solve quadratic equations by completing the square. So far we have learned two methods for solving a quadratic equation. Remember, the standard form of a quadratic is ax squared plus bx plus c is equal to 0. Factoring was the first method that we looked at, and it is useful when the quadratic expression can be factored easily. The second method we looked at was the square root method, which is useful when b is equal to 0. What about a quadratic equation that cannot be factored and b is not equal to 0? So if you recall, yesterday we looked at that x squared plus bx can be factored, and the factor would be x plus b divided by 2 squared if we add b divided by 2 squared to the end of our quadratic. This process is what we know as completing the square. So example number 1, we want to complete the square below and write the polynomial in factored form. So this is review of what we did yesterday. So we want to add a plus box to this side of our equation, and underneath that we have our factored form, which is x plus or minus something squared. So if you recall from yesterday, inside this box right here, we use b divided by 2 squared. In this factored form, we use b divided by 2. So the b in this problem is negative 12. b divided by 2 is negative 12 divided by 2, which equals negative 6. And b divided by 2 squared, negative 6 squared, is positive 36. So when we fill that information in, we know that our perfect square trinomial, we're going to put b divided by 2 squared in this box to create a perfect square trinomial, which means that our factors are the exact same thing. So in this case, it would be x minus 6. So let's take a look at example number 2. Completing the square can be used to solve a quadratic equation that cannot be factored. So x squared minus 4x minus 11 is a given prime quadratic. All right, you cannot factor it. So the first thing that we want to do is we want to use the addition property of equality to move the constant to the right-hand side of our problem. Step number 3, we want to add plus box to both sides of our problem. Step number 4 is we want to factor or use our b divided by 2. We'll combine our like terms on the right hand side, and that will go in this blank. So when we fill in these boxes right here, this is our perfect square trinomial. So in these boxes for step 3, we're going to use b divided by 2 squared. So if we list out our b, we know b is negative 4. b divided by 2, negative 4 divided by 2 is negative 2. So we can place b divided by 2 in that blank, or in our factor. b divided by 2 squared, negative 2 squared, goes in our 2 boxes. So wherever we have our squared term, we're going to put 4 in both of those boxes. When we combine like terms on the right-hand side, we are left with 15. So if we take it a step further and combine the square root property along with completing the square, we can solve for x, or the x-intercepts, in our quadratic equation. Step number 1 is to make sure our quadratic is set up with our constant on. So we want to move our constant to the right. After we move our constant to the right, so we have x squared plus 12x, we want to also add our plus box. So to move a positive 16, we subtract 16. And if you add something to one side of your equation, you have to add it to the other. Okay? If your a is not equal to 1, you need to divide by a in order to get that equal to 1 first. Step number 3, after we add our boxes and write our factored form below that, we need to complete the square. So in our boxes, our 2 boxes, we're going to use our b divided by 2 squared. And in our single factor, we're going to use our b divided by 2. So the b in this case is 12. So b equals 12. b divided by 2, 12 divided by 2 is equal to 6. And b divided by 2 squared, 6 squared is 36. So b divided by 2 squared is what goes in our 2 boxes. b divided by 2, which is our positive 6, goes in this blank. Then we combined our like terms on the right-hand side. So 36 minus 16 is positive 20. And now we want to continue solving using the square root property. So when we get to step 5, we're using the square root property, or solving by square roots, which is what we have been doing. So if we take our squared term is isolated to the inverse of squaring something is square rooting it. So we're left with x plus 6 is equal to plus or minus the square root of 20. The square root of 20 is not simplified. I know that 20 is divisible by the perfect square 4 times 5. The square root of 4 is 2, and the square root of 5 is simplified completely. So now what we need to do is we need to finish solving for x. So the inverse of plus 6 is minus 6. Negative 6 you want to put in front of your radical. And we have negative 6 plus 2 root 5. And we have negative 6 minus 2 square root 5 are the solutions to our quadratic equation. So let's try example number 4. They've already moved our constant to the right-hand side. The next thing that we need to do is, I notice that a is not equal to 1. So because a is not equal to 1, I need to divide everything by 3. So x squared minus 6x, you can go ahead and leave your space to add your plus box. 21 divided by 3 is 7. If we added a box to one side, we must add it to the other. We can write our factored form underneath our perfect square trinomial. And then off to the side, I'm going to write my b divided by 2, and my b divided by 2 squared. My b, you want to look at your new quadratic after you divide it by 3. So our b is negative 6. Negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9. Your b divided by 2 squared goes where you have 2 boxes. Your b divided by 2 goes in your factored form. After you complete the square, you need to continue solving. So 7 plus 9 is 16. We're going to write as the inverse, so we're going to solve using square roots. Square root undoes a square. X minus 3 equals plus or minus square root of 16. The square root of 16 is 4. I know to get x by itself, I need to add 3. So I get x is equal to 3 plus 4. X is equal to 3 minus 4. So my two solutions are 7 and negative 1. The last problem we want to look at is what value of b makes x squared plus bx plus 81 factor as a square. So remember, when we are creating a perfect square trinomial, we used b divided by 2 and b divided by 2 squared. This right here was b divided by 2 squared. So what number squared is 81? Well, I know that positive 9 squared is 81. So then I know in order to get this factor, I used b divided by 2. So if I set 9 equal to b divided by 2, the inverse of division is multiplication. So I then determine that b is equal to 18. So let's try that again. If we have x squared plus bx plus 16, in order to get my factor for my perfect square trinomial, I know I have to use b divided by 2. After I have my b divided by 2 in my factor, I square that and it becomes my perfect square trinomial. So what number squared is 16? 4 squared is 16. So if I set b divided by 2 equal to 4, solve for b by using inverse operations, I know that b is equal to 8. You now can complete your worksheet for day 8.